Hello children, in a previous class we discussed the numericals based on resolution of vectors. In today's class we will be discussing about the unit vector. Children, it seems to be very simple. Of course it is simple only, but it has so much of importance. So if you want to know the importance of the unit vector, first we must understand what is unit vector. So if we can understand what is unit vector, then only we can have better understanding about the use of the unit vector. Children, definition is very simple. The name itself will give you the definition. Unit vector. So that unit means what, children? 1 means the vector with magnitude 1. The vector with the magnitude 1. Or simply the vector whose magnitude is 1 is called actually unit vector. Means children, we know that vector means what actually? There must be 3 properties. One is vector should have a magnitude, vector should have a direction, and it also should obey the law of vector addition. So in that magnitude we are talking. So throughout our discussion, for us magnitude is a very important. If that magnitude is 1, if for any vector, children, if the magnitude is 1, then such a vector is called unit vector. Now, let us see first of all, children, here. So, how can we represent that unit vector and what is its importance? So, let us have the feel, children. The definition is very simple, right? Just to know the definition, you no need to listen to my class also, even just you can by heart. The vector whose magnitude is 1 is called unit vector. It's as simple as that. But let us have the feel. So what is a unit vector? How we can obtain the unit vector? For suppose, children, here. So let us consider the force vector. Let us consider the force vector. So here, as per our example, children, here, a force of 20 Newton is acting towards the east. Acting towards the east. Means here 20 is what actually? It's a magnitude. How much? How much? Means what? 20 Newtons. So here 20 is the number. 20 is a magnitude. So the magnitude of a vector is always scalar, right? Means it's a simple number. In which direction it is acting, children? It is acting towards east. So, force of 20 Newton is acting towards the east. Now, our point is that, let us say it's my question. So, my question is that, how can I get, children, how can I get a force of 1 Newton acting towards the east? Try to understand, children, in the same direction. I want the force to act in the same direction only, but with a magnitude 1. With a magnitude 1, which means what? I want to find out 1 Newton force acting towards east. So very simple. For suppose it is a vector 20 Newtons of east. Okay. Now how can I, from this, if I want to get a 1 Newton force which is acting towards the east, what I should do? I should divide with the 20, right? Yes or no? I must divide with the 20. Okay. Means what here? I am dividing. It's a magnitude. I am dividing the vector with its own magnitude. Then 20 cancel. Then what we get here? We get here 1 Newton force of towards east. Towards east. Means, children, here how much amount of force? 1 Newton acting towards east. What is the magnitude of this vector, children? 1. So now this vector only we can cut the unit vector. The representation will be f cap. F cap now. So now how we obtain, children, unit vector? Very simple. Any vector is divided with its own magnitude, then we get unit vector. Very simple it is. Very simple it is. Okay na? So here unit vector means simply we are dividing a vector with its own magnitude. As a result, we are getting a unit vector in that direction. Children, it's very important. So here unit vector gives a direction. It's only one. That is the important actually. So you can convert, for example, if you want to convert a scalar into a vector in a particular direction, what we have to do, children? Yes, whatever the direction you want vector. So multiply that particular scalar with that unit vector, then you will get the particular vector in that direction. Example. For suppose children, look at here. This is here, okay, towards north. So towards north, let us say unit vector is 1 meter per second. 1 meter per second towards north actually. Now, for example, I want like velocity vector with a 50 meter per second in a north direction. 50 meter per second north direction. For suppose children, it is a speed. This is, let us say, 50 is a magnitude. But if this magnitude, okay, is multiplied with this unit vector, what we are getting, children? 50 meter per second towards north. Now this is becoming a velocity vector. Try to understand, children. So you can convert any scalar into a vector in a particular direction by multiplying it with the unit vector in that direction. So in whatever the direction you want to obtain the vector, children, you take the unit vector in that particular direction and then multiply with that scalar. Then you will get the vector in that direction with these many times 50. See, your magnitude gives you what actually? How many times it is. That's it, very simple it is. So here it is a 1 meter per second velocity towards the north. Now this is what actually? 50 meter per second towards the north only. We got in the same direction. But the magnitude is increased by 50 times. Why? We multiplied with that actually. Okay, fine. Now let us see a representation in normal, in a general case. For suppose children, if A is a vector, excuse me. Yeah, let us say A is a vector, children, and mod A is its magnitude. Mod A is a magnitude. Now we will define the unit vector of this particular vector. How? Yes, in a simple manner. So this is a vector and divided with its own magnitude. Children, very important. So if any vector is divided with its own magnitude, then what do we get, children? Yes, we get a unit vector in that direction. Unit vector in that direction. Okay, so this unit vector is a dimensionless quantity. What is its importance? Just to give you only the direction. Children, let us extend our discussion to the Cartesian form to have a better understanding about the unit vectors. So as a part of that, now let us discuss the orthogonal unit vectors. Children, we studied about the unit vectors. I repeat once again, the vectors whose magnitude is equal to 1, okay, are called actually unit vectors. Now we are going to discuss about the orthogonal unit vectors. Let us recall once again, orthogonal vectors means what? Children, do you have about orthogonal vectors? Tell me, if you know what actually are orthogonal vectors, yes, pause the video, comment your answer. Okay, now what are orthogonal vectors? Children, it's very simple. It's very simple is that the vectors, for example, when I can say vector A and vector B are orthogonal vectors. So I can say these two vectors are orthogonal only when they are perpendicular to each other. Means what? The angle between the two vectors must be 90 degrees. It's very important. So the vectors which are mutually perpendicular to each other are called orthogonal vectors, or the vectors if the vectors, what we can say, the angle between the two vectors is the 90 degrees, then the two vectors are called orthogonal vectors. So that is about orthogonal vectors. And here unit vector means what? With the equal or unit magnitude. But now our discussion is orthogonal unit vectors, which means what here? That particular vector should be mutually perpendicular to each other and they should have magnitude as 1 only. So let us consider such a vectors. Okay, children. So here is a Cartesian form, x-axis, y-axis, z-axis. It's a 3-dimensional, right? Yes. Let us consider, children, a unit vector along the x-axis. Unit vector means what? Okay, in terms of mathematics, if you need, for example, displacement vector of 1 centimeter. Why 1 I am taking here? Yes, magnitude should be 1, right? Yes. So here, from here to here, let us take, okay, here to here. Okay, this is a 1 centimeter. Example I am telling you. So 1 centimeter in a x direction. 1 centimeter in a x direction. That is okay for a displacement. But in general, how can we represent that? Yes, so we can represent that with the I cap, children. So I cap is a unit vector along the x axis. This is what we go on using throughout the vectors, children. So I cap, whenever I cap will come to your mind, so wherever you can say I cap, you should think that yes, it is a vector, it's a unit vector which is acting along the x axis. Similarly, and here j cap is a unit vector along y axis, and here z, or you can say k cap is a unit vector along the z axis. So when I say unit vector, children, here, yes, magnitude of I cap is equal to the magnitude of j cap is equal to the magnitude of k cap is equal to 1. Why? Because they are unit vector, they should have magnitude as 1. And here we also can write like this: I square is equal to j square is equal to k square is equal to 1. Children, regarding this, actually we will be discussing in detail in a dot product, how I square is 1, j square is 1, k square. So for now, just you can remember it is okay na? So it's a magnitude is 1. So definitely with that we can say yes, I cap, j cap, k cap are unit vectors. But if you can see, children, here, yes, it is x axis I direction, what is the y axis j direction, and is the z axis k direction. How these two are? What is the angle between ij? 90, jk 90, ki 90 only. So they are even orthogonal vectors also. So children, here, so these are the vectors with a unit magnitude and they are mutually perpendicular to each other. That's what we can call I cap, j cap, k cap as orthogonal unit vector. Children, this is very, very, very important. Don't by heart, have the feel. So when you can have that feel only, it's very easy to you, because so with this we are not going to end, right? Throughout vectors we will be having a discussion with I cap, j cap, k cap. So why these are called orthogonal unit vectors? Because they are mutually perpendicular to each other and those magnitude is equal to 1. That's what they are called orthogonal unit vectors. Is that clear? Just copy this, we'll continue the discussion. Direction. Fine, children. Now, okay, by using the concept of unit vector, the thing is that let us represent the vectors given. Children, once again here, along x axis I cap, along y axis j cap, along z axis k cap, as well as along minus x axis minus I cap, along minus y axis minus j cap, along minus z axis minus k cap. Now by using this, now we have to represent the following vectors. Children, can you try this? Yes, pause the video and comment your answers. How can we represent all these vectors? 1, 2, 3, 4, 5, 6 vectors. Okay now? 3, 2, 1. Hope you have tried, got it. Okay, fine. Let me try, children. So here it is vector A. Okay. What they are saying here? Vector A has a magnitude 20. Okay, its magnitude is 20. Fine. 20. In the direction of plus axis. Along the plus axis, yes, I cap. That's it. Over. As simple as that. Come on, children. At least can you try now? Okay, na? Chalo. Let us try together. Okay, fine. So here now vector B. Okay, vector B of 15 magnitude. Okay, along minus y axis. So minus j cap. So this can be written as simply minus 15 j cap also. No problem at all. It is understood. Okay, fine. The third one, vector C. Okay, vector C of magnitude 10 acting towards the z. Towards the z, what, children? K cap. Okay, fine. Next, vector D. Vector D. So has a magnitude 5. Along y axis. What, children? It is simply a j cap. Okay. Now it is, I think, 2 dimensional. Okay. So vector P. Okay. Here is vector P. Okay. Has a magnitude 3 units in x-axis, okay, 3 units in a x-axis, okay, plus 4 units in a minus z direction, children. So 4 units in a minus z means what? K cap. So this can be written as it is 3 I cap minus 4 K cap. Okay, fine. So vector q has a magnitude 5 units in a minus y direction. Minus y direction, no problem at all. So it's a 5 units minus y direction. What is the unit vector, children? Minus j cap. Okay, minus j cap plus 10 units towards minus x direction. Minus x is what? It is a minus I cap. Now this is going to be a, so minus 5 j cap minus 10 I cap. Okay, fine. So this is actually, it's a 1 dimension and is a 2 dimension. Even same thing can be in a 3 dimension also, right? 3 dimensions. For suppose, you know, one more vector, let us say, so vector r. So it has a like a 3 units magnitude in a minus x direction and 5 units in a y direction and 3 units along so y. This is, for example, minus z axis. Then represent the vector r. Children, can you try this? So means here, so that particular vector has a magnitude along x axis, that is minus x axis, y axis, minus z axis. So 3 dimensional, right? Yes, it is as simple as that. Come on, vector r can be used. So it's a minus 3 I cap. Why I am writing minus 3 I cap, children? Yes, minus x direction, the unit vector is minus I. Okay, now y. So plus 5j and this is going to be a minus 3k. So cap is mandatory, children. So sometimes, you know, sometimes I might forget to put a cap, but you should understand that it's a unit vector only, because for a unit vector, representation of unit vector is what actually, for any alphabet, if you are putting that cap, then it means that that is a particular unit vector. Okay, na? So let us copy this, we will proceed. Today throat is not supporting, but still we should continue our class, right? Yes, just go ahead, come on, copy it. Find m is equal to how much? Children, let us solve the simple numericals to have more understanding about the unit vector. Yes, children. So yes, so any vector as we discussed, you know, if any vector is divided with its magnitude, then as a result we get a unit vector, right? So in a simple manner, so for example, if you want some x vector, let us say, so unit vector of x is nothing but what actually? Vector by its own magnitude. This is what actually we are going to apply. Now here vector a is given. Now we need to calculate its unit vector. So first what we have to do, children? Yes, let us find out its magnitude, right? So magnitude a is equal to how much, children? Yes, square root of minus 3i whole square plus what we can say 4j whole square. First we have to calculate the magnitude. Okay, so it is going to be how much, children? Here, yes, anyhow I square j square value is 1 only, so this will be 9 plus 4 sorry, 4 into 4 is how much? 16. So this is going to be a 25. Yes, so 5. So 5 is a magnitude. Now we need to have the unit vector of vector in that direction, right? Yes, so unit vector means, yes, as simple. So let a cap is unit vector, then vector a by its magnitude, that's it. Okay, now vector a is what? Yes, minus 3 I cap plus 4 j cap by its magnitude is 5. That's it, children. So now this is the unit vector of this vector. Okay, fine. Children, can you try the second one? Come on. So first what we have to do? Yes, we have to calculate the magnitude of the vector b. So now directly I will take it as a 5i square is how much? The 25 plus anyhow minus 12 k cap whole square, minus will become plus only, k square is 1. So 12 square is how much? It is a 144. So this will be 169. So this is going to be a 13. It's going to be a 13. Now let us write the, so let b cap is a unit vector of this vector, then it is going to be a vector by its own magnitude. So this will be how much later? 5 I cap minus 12 k cap by it is 13 children. So this is how actually we can calculate the unit vector of a given vector. Okay, come on children. Now the third one, what is given here? Third one, here if here is a vector is given, its magnitude is 1, means what? It is a unit vector. If like a 0 I cap plus 0.8 j cap plus c k cap is a unit vector, then find the value of c. So magnitude, so how to calculate the magnitude? Come on, use the formula. So here third one children, yes, so this is going to be a square root of 0.5 I whole square plus 0.8 j whole square plus c k cap whole square, okay, is equal to 1 as per the question. Magnitude is 1, right? Yes. Now this will become anyhow 0.5 square means what? 0.25, I square value is 1 only, plus 0.8 square means what? 0.64, j square value is 1, and this is c square, k square value is 1. Now it is equal to 1 children. Now square on both sides. So if you can do squaring version, this square root will get cancelled and 1 square will be anyhow, it's 1 only. So children here, so this is going to be 0.25 plus 0.84 is how much? 0.89 plus c square is equal to 1. Now this is c square is equal to 1 minus 0.89. This is going to be a 0.11. As c square is equal to 0.11 children, c is equal to square root of 0.11. So this is the answer, and in a simple manner we can calculate. Okay, fine. So next one also children, if 1 by 2 I cap plus 1 by 2 j cap plus m k cap is a unit vector, then find the m value. Find the m value children. Come on children, pause the video, just apply the same concept. Come on, this you have to do it. Children, why you have to do it? Yes, because you need a practice. You are the one going to write an exam. Okay, again and again the same thing children here. Yes, you can listen, but have some practice also. Okay, now come on, 3, 2, 1. Got the answer? Chalo, let me try. So similar same concept, let us follow this. So this is going to be a 1 by 2 I whole square. This will be 1 by 4 plus 1 by 2 j. Acha, first unit vector, right? So as it is given for us as a unit vector, so let us write. So step by step let us go. So let us not go directly. So means magnitude of this vector plus 1 by 2 j cap plus m k cap. Magnitude should be 1. This what actually is given in the question. So now let us go for the same concept here. So square root of this whole square will be 1 by 4. Children, I square value is 1. That's what I am not writing. Okay. So here also it is a 1 by 4 plus m is equal to 1. So square on both sides. So 1 by 4 plus 1 by 4 will be it is a 1 by 2 plus m is equal to 1. Children, here we did squaring on both sides. Okay. And m is equal to 1 minus 1 by 2. So hence m is equal to 1 by 2, or in opposite it can be given even 0.5 also. So children, this is how actually we can calculate, we can do the numericals based on the unit vectors. Just you copy this and we do 3 to 4 bit more numericals. Let us extend our discussion to the few more numericals. Okay, copy it. Q is equal to how much? Children, these 3 numericals are very, very, very important examination point of view. Are you able to see? So let me just adjust. I think you are able to see, right? Yes, fine children. Okay, so these 3 are very, 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 very important examination point of view. So as per the question, these children here, they are asking, see, one particle is going with a speed of 10 meter per second. Speed is given, means what? You also can call it as a magnitude of the velocity. Okay, now fine. So then they are asking us, means for that particular particle, displacement vector is this much. This is 2 I cap plus 3 j cap plus 5 k cap. Now, so they are asking us to calculate the velocity vector of that particular particle which is going with the 10 meter per second in the direction of displacement. In the direction of displacement, try to understand. So when they say that it is in the direction of a displacement, means first we need to calculate how to know the direction. Yes, that is what actually unit vector. So unit vector of that particular particle must be in the direction of what actually? The unit vector of the displacement. So for this our idea is, yes, they are asking us to calculate the unit vector, actually vector. So any vector, children, can be written as its unit vector multiplied by its own magnitude. This is a concept from the unit vector definition, children. The thing is that, yes, magnitude value is given 10 meter per second, but how to know the unit vector of that particular particle? I mean, what unit vector of the velocity? So they said it is in the direction of displacement. So in the direction of displacement, which means what here? The unit vector of velocity and the unit vector of the displacement are same. So which means what here? So here r cap is equal to the v cap. That's it. But how to calculate the r cap? Yes, let us calculate here. So here r cap is equal to r vector by its own magnitude. So this is what actually 2i cap plus 3j cap plus 5k cap. But its magnitude, so its magnitude is going to be a 2 square is 4 plus 3 square is 9 plus 5 square is 25. So this how much, children, here? 25 plus 4 is a 29 and a 38. So r vector is 2i cap plus 3j cap plus 5k cap by square root of 38. So this is what actually, children, unit vector of the position vector, so called displacement vector. But here they are asking us to calculate in that direction only, right? So the direction of the velocity also in this direction only. So unit vector will be same. Okay, so this is going to be, so in the place of v vector, v unit vector, you can write r cap, this one. So the answer is going to be 2i cap plus 3j cap plus 5k cap by root 38. Mod v value is how much? It is a into 10. So if you can multiply, this is 20i cap plus 30j cap plus 50k cap by root 38. Now this is the velocity vector. So it is a meter per second velocity vector with a magnitude 10 meter per second and in the direction of displacement. Here you may get a one doubt. Sir, we are multiplying with this to this 10. Will there be any change? No change, my dear. Why? If you can calculate its magnitude, you will get as a 1 only. You get magnitude is 1. So 1 into 10 will be 10 only. So there is no change in the magnitude actually. Only direction. Only direction. Come on, children. Let us follow the same concept to this also. Acha, here in this question, vector A, vector B is given. Now they are asking us to find the vector C whose magnitude is equal to the vector B and which is parallel to the vector A. Which is parallel to the vector A. First, children, let us write here. Vector C can be written as, yes, its unit vector into its magnitude. But as per the question, they are saying that magnitude of the vector C must be equal to the magnitude of B. So which means what? Magnitude of C must be equal to magnitude of B. Okay, that is fine. It's very easy to us to calculate the magnitude. Let us calculate the magnitude of vector B, right? Yes. So this will be how much more? This is 7 square 49, 3 square 9. So this is going to be a root 56. So this is even vector C also. They are asking, children, they are asking us to calculate the vector C such a way that its magnitude must be equal to the magnitude of B. And that particular vector C must be parallel to vector A, children. Parallel to vector A. So now, what is that vector which is parallel to the vector A means what actually? Unit vector only. It's a unit vector. First, let us calculate the unit vector of A. So unit vector of A can be calculated like this, right? So it's the vector A by its magnitude. So this is going to be 3i cap plus 4j cap by, children, square root of 3 square is 9 plus 4 square is 16. So 25 means 5. 3i cap plus 4j cap by, it is a 5. So this is a vector, what we call unit vector of this vector A. So now you may get wonder, sir, why are we calculating that? Because they asked us to calculate the vector C with the magnitude equal to the vector B and should be parallel to the vector A. Parallel to vector A is what actually? Unit vector only. So this is vector C, right? Yes. So we have to represent like this. So as C dash is equal to vector C into magnitude of C. So this is going to be a cap, because both parallel means unit vector is in the same direction. So and it is a B vector. You multiply now. So that is vector unit vector is how much? It is a 3 I cap plus 4 j cap by 5 into root 56. So simply we can write the vector C is equal to root 56 into 3 I cap plus 4 j cap by 5. So now this is a vector C whose magnitude is equal to the magnitude of B and which is parallel to the vector A. Clear? Fine. Now children, so as per this question, if P plus Q is a unit vector along x-axis, children, along x-axis the unit vector is what? Yes, it is I cap. So indirectly it is given that P vector plus Q vector is equal to I cap. So here P is given, they are asking us to calculate the Q value. Very simple. Substitute this in the place of P here, that is I cap minus j cap plus k cap plus q vector is equal to I cap. Take this right side, this is going to be a q vector is equal to I cap minus of I cap minus j cap plus 4 k cap. So when you multiply with this entire thing, this will become minus I plus j minus k cap. So this I cap minus I cap will get cancelled. So the answer is going to be a j cap minus k cap. So this is the vector Q. Is it clear, children? Just copy this. We do one important numerical. Very important. Just copy this. We'll come to that actually. Yeah, children. So as per the question given, so it is given that here, it is given that, so the sum of the two unit vectors, let us say A cap is a one unit vector plus B cap is a unit vector, is equal to the vector with unit magnitude. Means what? It is also unit vector only. Okay, fine. Then they are asking us to find the magnitude of the differences of these two unit vectors is how much. This is how actually they are asking. Children, actually this numerical, of course, why we are discussing this numerical here? Because it is purely related to the unit vector. But here parallelogram of law of vector addition also is involved. So once I will tell you the formula, later we will have a discussion. So what is that formula, children, here? Yes, so here for example here, so let me write here only. So vector P plus vector Q, its magnitude. This can be written as square root of P square plus Q square plus 2PQ cos theta. So this is what actually, okay, you remember this formula. So later we will have a discussion in detail about the parallelogram of law of vector addition. Okay, fine. So now children, so A plus B is equal to C cap. Let us take that only. So let us take this magnitude, right? Yes. So from this, so apply this formula here. So what will happen? This can be A square plus B square plus 2AB cos theta is equal to C square. But children, can I say here A square is equal to B square is equal to C square is equal to 1? Why? Because they are unit vectors. Their magnitude is equal to 1. 1 square will be 1 only. Okay, fine. So let us substitute here. Substitute here. This will 1 square is 1 plus 1 plus 2 into 1 into 1, 2 cos theta is equal to 1. Now square on both sides. This will be 2 plus 2 cos theta is equal to 1, and here 2 cos theta is equal to minus 1, and cos theta is equal to, children, minus 1 by 2. Just keep aside. So we got cos theta is equal to minus 1 by 2. Now children, so they are asking us to calculate this, right? Okay, let us take this. So this magnitude, this can be written as A minus B cap, can be written as square root of A square plus B square minus 2AB cos theta. 2AB cos theta. So now as we know that yes, a square value is 1 plus 1 minus 2 into 1 into 1 minus 2, and cos theta value we got minus 1 by 2, put here, that's it. So here 2 to get cancelled, minus of minus plus, so this will be 1 plus 1 plus 1, this will be root 3 units, that's it. So it is the magnitude of the difference of these two vectors is root 3. So children, so this is today's class. We discussed unit vector and followed by few numericals. Is that clear, children? Fine. So again my advice is that children, whenever we are solving a numericals, just pause the video, try your level best. Whether you get or not, that is second thing, but you have to try. Is it clear? Fine children. Okay, we'll meet you in the next class. Thank you so much. All the very best.